Hello everyone. In this recording, we are going to talk about basic differentiation rules. The first rule that we are going to talk about is the constant rule, which says that if you have a constant function, then its derivative is 0. Now, at this point, try to understand what is a constant. A constant is something that doesn't change. It's fixed. For example, consider the function pi. Now, as you can see, pi doesn't have any x in it. The independent variable x is missing in this function. As a result, you can say that the derivative of this function is 0. Why is that? Because derivative is the instantaneous rate of change of a function, right? Here your function is not changing with respect to x. It's fixed, it's a constant. Therefore, the instantaneous rate of change of this function with respect to x is 0. As a result, you can say that its derivative with respect to x is 0. Let's take another example. Let's take fx as e to the power 2. What do you think would be the derivative? Yes, indeed, it is 0. Why? Because I don't spot any x over here, which means that this is a constant function. As a result, the instantaneous rate of change of this function with respect to x is 0, meaning that the derivative of this function with respect to x is 0. Okay, the next rule that we talk about is the power rule. Power rule says that if your function is defined as x to the power n, where this n is fixed, then its derivative is given as n times x to the power n minus 1. Now let us consider some examples for this one. What if my function is defined as x to the power 4? Well, then your derivative will be 4, which comes to the front, and the power gets decreased by 1. So 4 minus 1, that's just 3. Similarly, if your function is defined as x to the power negative 2, then its derivative would be, which is same as now, one most important thing that you should note here, and this is where students get confused, is what is the derivative of x? Now, please note here that x is same as x to the power 1. So when you use the power rule to find its derivative, that would be 1 times x to the power 1 minus 1, that is 1 x to the power 0. And what is x to the power 0? Yep, that is indeed 1. Okay, so please remember, derivative of x is 1. Okay, now let's test you on these two rules. Give me the derivative of the following. Let's try the first one. What do you think? Look at the function here. I cannot spot any x over here, which means this is a constant function. It doesn't change with respect to x. Therefore, has a derivative of 0. Getting to the second one, please note that 1 over x to the power 4 can be written as x to the power negative 4. So please try to rewrite this function in this way before you even differentiate it. Now, if you differentiate it using the power rule, you will get negative 4 x to the power negative 5, or you could write it as negative 4 over x to the power 5. And the last one, its derivative is 7 times x to the power 7 minus 1, or you can say 7 times x to the 6. All right, let's go ahead and talk about a few more rules. The third rule that you should know is that if your function looks like this, c times x to the n, where c and this number n, they are fixed, then the derivative of f with respect to x is given by c times the derivative of x to the n, which is same as c times n times x to the n minus 1. Let's consider some examples to understand this rule. Going with the first one, let us say your function is 2 times x to the power 3. Then, when you take the derivative of this function, that is 2 times the derivative of x cubed, which according to power rule is 3 times x squared. All right, so if a constant is multiplied to your function, you can keep it out and differentiate that function. That's the whole idea. For example, if your function is e to the power 2 times x to the power 4, then the derivative will be e to the power 2 times the derivative of x to the power 4, which is 4 times x cubed. Want to try another one? Here you go. Please find the derivative. For the first case, when you move this x in the denominator up, its power changes signs. In the second case again, if you move this up, the power is going to change sign. So please rewrite the functions in this manner before you even start differentiating. The next rule that we are going to talk about says that if you have to find the derivative of f of x plus g of x, and that will be given by f prime x plus g prime x. That is the derivative of f with respect to x plus the derivative of g with respect to x. And you can do the same thing with the difference of f and g. That is, to find the derivative of f of x minus g of x, all you have to do is find the derivative of f minus the derivative of g. Now the question is, how do I apply this rule? So let's consider this by means of an example. Let us say I have to find the derivative of 3x squared plus 7x plus 8. Then the rule says that you have to take the derivative of 3x squared, which is same as 6x, plus the derivative of 7x, which is same as 7, plus the derivative of 8, which is 0. So your answer will be 6x plus 7. Let's try one more. Now, before you find the derivative of this function, make sure you rewrite this function in the following form. And now you are ready to differentiate it. Derivative of 2, 0. Derivative of the second term is given by and you are done. Would you like to try one more? Okay. Derivative of 9e, 0. Why? Because 9e is a constant. Derivative of 8 over e again is 0 because it is a constant. Now, before you find the derivative of 8 over x, please note that you can write it as 8x inverse. Now, if you find the derivative using the power rule, that's how it looks like. For the next term too, rewrite it before you differentiate. Now use the power rule. Derivative of 10x will be 10. Why? Because the derivative of x is 1. And you apply the power rule to differentiate the last term also.